know already we have started, but again I'm going to introduce the chapter 3. Let's see what we are going to study in chapter 3. Okay, oh, somebody is there. Okay, so children, I guess I have done, I think so. It's too much, like it's too late now. I just don't know why I'm getting this. Okay, fine. This is the introduction of the chapter. This whole thing, if you observe this whole thing, it's the complete chapter 3. In this chapter 3, we are going to study about the metals, non-metals, which already we have studied, about the physical properties of metals and chemical properties of metals. Also, we are going to see the physical and chemical properties of non-metals. And then we are going to study the corrosion process, how already we have studied in chapter 1, but again because it is related to metals, also we are going to study in this chapter. So next one, children, we have the rusting part, how rusting takes place. Okay, what actually is rusting, also we are going to study in this chapter. And then we are going to study the very 100%, children, every time, many a years this type of question is asked, what are ionic compounds and what are the covalent compounds. This question is mainly, many a times this question is asked in your paper. Okay, many a times, so you have to be very careful. You have to just observe properly when I'm teaching you. So then ionic compounds, we are going to study about the ionic compounds and covalent compounds. And last part of the chapter is very important, that is about ores. So like in the surroundings, children, when we go to ground, okay, when we go for like on the sports day and all, we go on the ground. So on the ground, children, we find many different types of pebbles, many different type of stones we find on the ground. And is that all these stones are black in color? No, it's not compulsory. We have different shades of colors. Okay, we have different types of pebbles and stones on the ground. So there is a study of rock. Actually, the metals which we use, gold, silver, iron, zinc, copper, they are actually present in a rock, in the form of a rock. So the person should know to identify which ore has that metal. Okay, which ore has that metal, and how to separate. Like for example, gold, when we look at the rock, it's generally blackish, brownish or whitish in color. But is that like when you're going to do the, like if you observe the ores of the metals, they are also similar to a rock. Okay, equal to a rock. But it's the person who studies the rock identifies which metal is there in that ore, and the extraction process, how the metal is taken from the rocks. Okay, how the metal is taken or how the metal is extracted from the rock is study is the thing which we are going to study in this chapter. So there are various methods of taking or extracting the metal from the ores. So and the chapter ends. This is the thing which we are going to study. We are going to study about metals, non-metals, corrosion, rusting, and then ionic compounds, covalent compounds. Also, we are going to study what actually is ore and how the metals are extracted from the ores. So, in the previous session, I don't know how much you remember, because 3 weeks past, I think 2 or 3 weeks past, I had introduced this chapter, and I guess like I don't know whether you'll remember anything. But so let's see, children. We will study the physical properties. Just we will see, I'll just introduce the physical properties of metals and non-metals. So what are the physical properties of the, what is the meaning of physical property? Physical property is the outer property, only general properties. Like for example, if you look at a spinach, okay, if you look at a spinach, what will be the physical property of a spinach? So physical property will be that it's green in color, it has leaves. Okay, it has leaves, it has like it's available in bunch, so it has veins on the leaves. So you can just look at the substance, and you can identify the properties. That properties are the physical properties. Physical properties means outer properties. And then chemical properties are the internal properties, like what spinach contains, which acid, which minerals, which proteins it contains. Okay, so what actually it contains, that is the chemical property, okay, and how it reacts with when you add spinach into turmeric, when you add spinach into boiled water, if there are any color changes, do you find like spinach when you heat a lot it becomes, because it's light green, and when you heat a lot it becomes dark green. What is the why actually it turns dark green? So that is a kind of color changes. You will find some properties are changed. That properties are actually the chemical properties. So we have studied about the physical properties, like metals are solid and non-metals are brittle, okay, especially they are brittle means you can break easily, you can break off any of the non-metal, but so they exist in solids, liquids and gaseous state. So all the metals are lustrous, they have a lot of shine, okay, like for example gold, silver, then just take iron, freshly new, like new iron sheets, you will find they are very shiny. And then non-metals, they are non-lustrous, they don't have any shine. Then we have malleability and ductility, that is if it is any of the substance can be beaten into sheets, that is the property of malleability, like rooftop, that is the flat sheet. Then jewelry flat, we made like jewelry, if you find the jewelers, they make nice flat necklace and the other bangles and all, it is converted into flat sheets, okay, even gold coins. So then we have ductility, that is the property of converting a substance or a metal into long wires. So these are the properties of the metals and non-metals. So high and they are very hard, metals are very hard and they have high density, they're very heavy ones, okay, all the metals are very tough ones, very hard ones. And then they are good conductors of heat and electricity. All the metals, they are good conductor of heat and they conduct electricity, okay. What is the role of conductor? He gives us the ticket so that we can travel from one place to the another. So same way children, this also, the material, the conductor conducts heat from heat or electricity from one source to the another. Like for example is that when you switch on the button, it's going, whatever fan light, it's going to, like it's going to work after one day or anything? No, immediately when you on the fan, immediately when you on the light, continues, like you'll within a fraction of minute it gets on children. Yes, within the just go and on the button now. If you all just see your phone also, within a fraction of minute it works. Charger also, just see any, when your mother uses mixer grinder, so when she ons the mixer grinder, within a fraction of second the mixer grinder blends the material. So same way children, same way, what actually is used inside those wires? A conductor which conducts the electricity. Then we have the they are the good conductors, metals, and metals, they are good conductors of heat and electricity, and they have high melting and boiling point. So this is a differentiation between metals and non-metals. So keep in mind children, whatever properties, all the positive properties, they are metals are, they are ductile, they are lustrous, they are sonorous, they are malleable, they are good conductors, they are they have high melting point and boiling point. Whatever positive points are there, it comes under the category of metals. That means all metals are, they have some sort of properties. But whatever properties metals have, the non-metals will have the total opposite properties. Like total, if metals are good conductors, non-metals are bad conductors. If metals are lustrous, non-metals are non-lustrous. So this is the differentiation between metals and non-metals. So these are the physical properties which we have studied, and this is the complete description of the chapter. So I don't know, just don't ignore those advertisements children. I know what's wrong, something is wrong, I have to delete those advertisements. So fine, let's begin with chapter. I know that this is very important children, because if I'm going on speaking something and you are just looking here and there, your attention will go here and there, and I don't want that children, okay. I don't want that you're looking here. I don't know how, so a lot of advertisement children, it's a, just ignore those. I'm just trying to admit the students, those who have, yeah, okay. So this, I'm just show you something children which is very very important, okay. So okay, very important, this is the okay, fine. Today I don't know, nothing is working. This happens when you handle a new device. This happens, children. Just ignore. So when I'm going on speaking, children, you will be just thinking, you will be wondering what is happening and what Mrs. speaking, what is happening around me. Okay, you will be. It's going to be very boring if you don't have anything in front of you. Okay, even if I'm going to look at you and if I'm going to speak, you will get tired to look at me. Miss, what Mrs. saying? It's so boring. So I've brought something for you. This is your textbook PDF, as I've shown you in the previous class also. So this is the PDF where we have the chapter 3, metals and non-metals, and the physical properties. On the first page we have the physical properties along with the activities I have explained you in the last class. The second page also we have the physical properties, that they are good conductors. We have certain activities which describes whether a material is good conductor or wo bura conductor hai. Okay, that is a bad conductor. So then one we have seen about the non-metals. Okay, the second and third page also you have something about the non-metals. So non-metals also, what are the properties of non-metals. So first four pages are related to the physical properties of metals and non-metals, and then go to the fifth page. Okay, let's go to the fifth page. Also this is over, children, I think so, but even though I'm just going to revise because we have joined, you have all have joined after many days. So then on the fifth page you have the केमिकल प्रॉपर्टीज. केमिकल प्रॉपर्टीज मीन्स वो सब्सटेंस केमिकली कैसे रिएक्ट करता है. ओके, हाउ डज इट, व्हाट केमिकली रिएक्शन मीन्स कुछ गैस इवॉल्व, एनीथिंग गैस इज इवॉल्व, और यू विल फाइंड एनी कलर इज इवॉल्व, लाइक चेंजेस आर देयर, कलर चेंजेस और एनी चेंजेस इन टेम्परेचर. So on the fifth page of the textbook or the chapter, you will find the chemical properties of the metals. So first property is metals plus oxygen gives metal oxide. Okay, I'll just zoom and I'll just show it to you. Metal plus oxygen gives metal oxide. So children, keep in mind, anything, okay, if I'm saying anything on this planet is burning. Okay, this I have told you earlier, but even though I want you to know, you burn anything, paper, if you burn paper, if you burn wood, if you burn cotton, if you burn any plants leaves, okay, anything, if you dry leaves, if you burn anything, what actually is happening there. Okay, now when you were a kid, when you were like looking at a fire, small kids, they get fascinated. Yeah, they're fascinated. Something is very interesting happening in front of their eye. They watch the flames and all. But now you're grown up children, you should know what, when something is burned during holy time, during any festival, something is burning, means what actually is happening in your house. Also, when incense stick is burned, when your mother lights a lamp, when you burn a candle when there is no electricity, so what actually is happening there, children? Keep in mind, chemistry has taught you that anything, if it is any material, if it is burning, any combustible substance, if it burns, you should keep in mind there is the main hero involved in this is oxygen gas. The oxygen gas enables the burning process. So if you are burning any metal, now ये तो बहुत दूर की चीज़ है. Imagine now paper, if I'm discussing about burning of paper, cotton and other wood, that is normally you have seen in front of your eye, you have seen those materials. But imagine if you are burning a metal. Okay, this is the first practical you are going to, I hope so the school reopens, because this is the first practical, that is the burning of magnesium ribbon. Okay, in the chapter 1 only we were having the practical. I think somebody has joined. Yes. No. Okay, no. So this is the practical which we have studied, that metal plus oxygen. Keep in mind, any of the thing if you burn, that means it is reacting with oxygen. Oxygen तो बनता ही है वहाँ पे. Without oxygen, that process is not possible. Okay, if you just close if you light a candle and if you invert a glass, okay, there's no air into that glass, so obviously we have performed this experiment. So वो candle burn नहीं होगा. Why it won't burn? Because there's no oxygen. Yes, so same thing children, keep in mind, जब भी you are burning anything, whenever you are burning anything, oxygen is involved there. So metal plus oxygen gives metal oxide. Okay, obviously metal को oxygen मिल गया तो that is going to form metal oxide. So same way some examples are given: copper plus oxygen, copper oxide; aluminum plus oxygen, aluminum oxide; then sodium plus oxygen, okay, sodium oxide. So we have different reactions. Okay, then that will we will just I think I guess this is over already, but just kind of reaction. Okay, then children, there are some okay, keep in mind this was about the combustion process where oxygen reacts with the metals. Now this is very important, I guess this is not over, okay, this part very important. So children, there are some metals, wait, just pay attention, don't look here and there. Don't look here and there, just look at the screen, and your eyes on the screen and yours just should be very attentive. Listen to me. So children, about, as I have told you that metals, when it reacts with oxygen, it gives the oxide of that metal, that is metal oxide. Here there are some different, like, it is exception, and mark my words, this thing is very important, that is about the amphoteric oxide. Okay, abhi ye to, if obviously if the word is different means the properties also will be different. Okay, so amphoteric oxides, look at this word amphoteric oxide, ye to naya hai, kuch to bhi hai, something new. So amphoteric oxide is something different, you have to pay attention. So amphoteric oxide, look at this, aluminium oxide, okay, other metals they just simply they form oxides, but aluminium oxide is something different, okay, something different. Why it is something different, we are going to see here now. So aluminium oxide, the formula of aluminium oxide is Al2O3. Okay, so what is happening now, look at this, this is very paltu baji wala. Okay, paltu baji means party badlu, you know what is the meaning of party badlu? If your father is like something happens in your house, like something where what you do know what is, like one time you are going to support your brother, one time you are going to support your sister, one time it's a kind of party badlu time, like one time you the supporting systems are going to be changed. So like you are very manipulative means what, your behavior changes. Like for example, the way you behave with your friend, can you behave with your parents, or you can you behave with your teacher? No. When you're talking to your teachers, your way of talking will be different, you will talk in a different respectful way. Are you going to tell like with your friends like something different? I have seen in the class, ye be za be, yeah, so many times I have told you also, ye be za be, you're just very friendly with your friends. Yeah, so every time you behave in a very different manner, okay, in like in front of shopkeeper, or if you go to the like any stranger, you behave in a very different way. Same way children, this amphoteric oxide, okay, this aluminium oxide is known as amphoteric oxide. Keep in mind, amphoteric oxide aaya to A for amphoteric, A for aluminium. Okay, so aluminium oxide is amphoteric oxide. क्यों आई amphoteric oxide है? Let's see now. Okay, so you have to keep in mind, so when any of the metal, when it reacts with oxygen, okay, अभी वो oxygen से के साथ react हुआ, what you are going to get? Metal oxide. That metal oxide, if you are going to put into what, okay, you are just going to test with a litmus paper, you are going to find that metal oxide is basic in nature. Basic in nature means litmus test will be what? B for basic, B for blue, so red litmus will turn blue. So metal oxides are basic in nature and non-metal oxide are acidic nature. Okay, keep in mind, you have to keep in mind, जो metal oxide form होगा that will be basic in nature. They have a basic nature, मतलब red litmus turns blue. But when non-metals they form the oxides, that is non-metal oxides, those are acidic in nature. If I'm saying basic in nature, acidic in nature, how you are going to find that it is basic in nature and acidic in nature? With the help of the litmus test you have seen in your previous class. So as acidic in nature, basic in nature, so you have to remember that metals, they form basic oxides, and non-metals, you have to remember that non-metals they form acidic oxides. तो ये तो something is different. Okay, I'll just show you this fellow. This fellow is something different. Okay, like generally metal, where it went, something is wrong today, whole day something is mess. Okay, so if I'm saying that metals they form, okay, metals they form oxides. Okay, जो metals के oxide है, मतलब metals react with oxygen and it forms metal oxide. So metal oxides, okay, so metal oxides they form like they are going to form basic, they are basic in nature because you are going to make use of that litmus paper and you are going to find out वो acidic है या basic है. So some metals such as ये aluminium तो है and zinc, they are different. Okay, क्योंकि now I said that metal जो oxides form हुए हैं those are basic in nature. I said just now that is red litmus turns blue. But this fellow, that aluminium oxide and zinc oxide, they are considered as amphoteric oxide. क्यों amphoteric oxide? Because ये तो पार्टी बदलू है. Okay, what type of पार्टी बदलू? वो like वो acidic oxide, like look at this. When aluminium oxide is added in acid, okay, जब वो acid के साथ react करता है, okay, you are going to find that it shows the reaction with acids also. Okay, it shows the reaction with any of the acid. It forms salt and water, and it aluminium oxide base के साथ react करेगा, that you are going to find NaOH and it forms salt and water. Okay, मतलब it shows the reaction with acid के साथ भी react कर रहा है, basic के साथ भी react कर रहा है, and it's going to show the products form are salt and water. So you have to remember, children, that this example is something different. Because as I have said, copper oxide, and then we have sodium oxide. So other metals, they have some other property. क्योंकि उनके oxide you are going to find they are basic in nature. उनका property क्या है? Basic. Red litmus turns blue. But this fellow, this aluminium oxide, ये something different है. Okay, this is something exception. क्योंकि ये aluminium oxide, it reacts with an acid also and it reacts with a base also. So when it reacts with an acid also and when it reacts with a base also, it gives the same product. Salt भी form हो रहा है, water भी form हो रहा है. So you have to remember this example as this aluminium oxide is amphoteric oxide. So if in exam they will ask what are amphoteric oxide, so you are going to tell that such metal oxides which reacts with, तो दोनों के साथ everywhere it reacts in the same manner. So amphoteric oxide is something different, I said. So these amphoteric oxide, they react with both acids and bases to produce salt and water. Look at the example. Aluminium oxide is Al2O3 plus HCl gives, ये तो salt दे रहा है, AlCl3, that is aluminium chloride plus water. Look at the aluminium chloride, aluminium oxide, if it reacts with a base, again you are going to get a salt and again you are going to get a water. Matlab this thing is something different. Keep in mind. Okay. So next one, most metal oxides are insoluble in water and some of these dissolve in water to form alkalis. Alkalis are nothing but those are bases. Sodium oxide and potassium oxide dissolve in water to produce alkalis. Okay, alkalis are nothing but any of the base, because all bases cannot be mixed up into water. They don't dissolve into water. But you will find that only you'll find that some bases they get mixed up into water, and that if I'm just taking some bases, those are sodium hydroxide, that is NaOH, which is commonly used, potassium hydroxide, that is KOH. Now these two are at least they are the at the top list. They are the top rankers, top 10 students we have in the classroom. Same way these two fellow, sodium and potassium, they are at the top. They are the naughtiest children in the class, or they are the naughtiest elements, and they are at the top. You are going to find that sodium and potassium, they are at the top. So this react in a very different way. When they are added into water, if you take sodium and potassium, first of all their properties are different. You will find they are so hard. Okay, like, yeah, is that hard or soft, children? Yes, those are soft. They have a very soft paneer like structure. When you take any of the metal, when you cut any of the metal, like if I sit with a knife and I start cutting my window panes or window like doors or the locks or any key, if we cannot cut it, children, because those are hard metals. But when I try to cut this sodium and potassium, they are very soft. Okay, they are very soft. They have a very soft structure like paneer. Easily we can cut it with the help of a knife. So when sodium, imagine they are so dangerous. I think many a times I have told you about sodium and potassium. And even I'm going to show you about the reactivity series. I'll just complete this part and then we'll go back to reactivity series, which is going to help you to understand how actually the metals react. So sodium and potassium, as I have told you, they are very, very soft ones, and when you just expose it on into the normal temperature also, ye dhamaka, okay, you'll find lot of dhamaka there, it catches fire. So when imagine the sodium and potassium, they are very corrosive, they are just, you will find they catch fire very soon. So they are always submerged, they are just placed or stored into kerosene because they're very reactive, they will catch fire very fatak say, if you take out from the bottle it catches fire. So you have to be very careful when you use sodium and potassium for your like in your chemistry lab in your future. So when you imagine bahar ke temperature mein it's going to catch fire, so what happens when you put into water? In water at least it will be like Diwali crackers only, dhamaka, Lakshmi bomb, this volcano and all, yeah. So sodium and potassium when you add into water, first thing, obviously it's a kind of exothermic reaction because lot of dhamaka, lot of heat will be given out, and you will find an alkali, that is NaOH and KOH. Okay, you will find this alkalis will be produced because they get dissolved into water. So this was the part, children. This was the, okay, I'll just show you children something so that you will understand it clearly. So keep in mind children, now at present, if I am going to, like if you're not in front of me, but if you would have in front of me, I would have given that example. Like simply if I'm going to give you, like this is the very important part. So in your house, okay, like something happens, like you are brothers and sisters, something happens children, like you there's a fight between you, and it's the fault of your sister or your small brother, your younger brother, okay, and if your mother or father shouts at you, so you're going to feel bad. Some people, like some student, like you're so going to feel so bad that it's her mistake, it's his mistake, and you're going to shout at me, it's very bad na. So you are going to react in a different way. Different way means you start clarifying, no mama, she did something, he did something. You start clarifying yourself, you just start justifying yourself that I didn't do anything, he did, she did. So that's a kind of justification you're going to give. You react in a different way. And some students, like some in your class only, some students are going to be so quiet, no mummy shouted at me, I'm going to be quiet. Okay, some students are going to get angry, mummy why did you, like you're going to get angry, mummy it's her fault and you have shouted at me. It's very bad na, like you're getting shoutings, you're getting scoldings because of some other person. So that's very bad children. So same way children, you all are going to react in a different way. So when I'm going, this is example 2 now. If I send one activity in the group, okay, if I'm going, that recent one only, song activity, element song I had sent in the group. So when you read the message that Miss has sent some activity in the group, so some students are going to react in a different, why song, I don't know to sing, no Baba, why Miss has sent this. Some students are going to start thinking songs, that which song, which tone. Even I had expected that some students will use the Bollywood songs as ringtones, like tones. I thought that you will use some Bollywood songs. Anyhow, you sing songs in the house, Bollywood songs. So you would have attached those Bollywood tones to your elements. Fine, others, those who have submitted, it was fine. The students, some students will not read the message, what Miss has sent. Every time Miss sends activity, why should I read, let it be. Every child in the class who reads the message is going to react in a different way. Some students immediately will be excited, wow, very nice Miss, this activity is very good, I'll start doing it. So then some students will say, no, I have English activity also, I have history activity also, I have this activity also, I have those activities also. So you will just try to manage yourself that I'm going to do these activities in this order. So this type of reactions are you are going to show children. Every child is going to react in a different way. Now in your lockdown now, okay, it's your lockdown, even though it's unlocked, but you are at home now. Some students may be trying some new dishes. Okay, you're trying some, while using some, if you're near burner, you're trying to use like some utensils also. By mistake, if you get, your finger gets burnt off. Is that you're going to laugh, children? Any of the child is going to laugh? Yeah, you're going to show happiness. Yay, my finger burned off. No, you're not going to show that kind of happiness. You may cry. You're just going. Some students may go to the kitchen, or you're going to use your parents, and you'll use some home remedies. Some are going to just apply some ointment on it. Okay, Bernol or something. So every child is different. Every child is different in the classroom. Whichever children are there here, you have a way of reacting. Okay, you react in a different way. Same way, children, I had shown you the periodic table. I think you know about the, yes, I'm so bad these advertisements. I'm just fed up of these advertisements. So the periodic table, children, okay. Somebody has joined now. Okay, fine. In the periodic table, children, okay, we have around 118 element. I have 118 element, that is 118 element, as I have told you earlier. So out of that 118 element, okay, many of the elements are metals. Okay, that day I showed you that coloration, like the red color, the many of the metals are many of the elements are metals. Then you will find some elements are the non-metals, and at the last one, at least they are the laziest one, आना ही नहीं है, कुछ करना ही नहीं है, that is no reaction. So they are stable ones. So at the last one, they are the stable ones. So then in middle, between the metals and non-metals, you are going to find the metalloids. So in the metalloids, you are going to find they follow the property, they have the properties, they possess the properties of metals as well as the non-metals. So they are in the center, तो metals भी है, non-metals भी है. So children, some metals are classified according to their reactivity series. This series you have to by heart it. When I'm going to come, I don't know this week, but please send me, you are going to everyone, same way the elements, I'm not going to give you any deadline, no last dates, children, but whenever you have free time, just by heart this series, and you can send me the video personally that yes miss I have by hearted, and I'm not going to show it to anyone, children, because I want you to learn the series. That's it. Okay, that is the main aim. So learn the series, it's very important, as the series on the basis of the series only there is the continuation of chapter. It's the complete the next chapter, what we can say, the complete chapter you will understand. Okay, so keep in mind, revise the series properly. So in the series we have potassium, sodium, those are the hero of the metals. Why they are considered as the hero? Because as I was explaining you about the reactivity. If you are going to cry, if you're going to if you get hurt, you're going to cry, you're going to smile, you're going to laugh. So the way you're going to react, everybody is not going to react in the same manner. Everybody is different. So same way, children, all metals have the different reactivity. Okay, they react in a different way. So what type of if you observe the reactivity series at the top, okay, we have the dhamake wale elements, that is the sodium and potassium. They have lot of they react in a very rash, very quickly they react. So according to the reactivity of the elements, reaction, kaise reaction dete, like on the Facebook and all, you have the reactions, smileys, different type of smileys, smiley wala, sad smileys, even smileys also we have different emojis and all. So those emojis also, they show different type of reactions. Same way here also, metals also, they react in a different manner, and according to their reactivity, they are arranged in this reactivity series. So in the reactivity series, we have the topmost dhamake wale elements, that is the sodium and potassium. Okay, children, they are so reactive. Children, they are so reactive. Literally, earlier I have told you that it's equal to a paneer. Literally, you can cut that metals with a knife, with the help of a knife. Literally, they are so soft like a paneer or rubber, eraser. We can cut it with the help of a knife. And you should remember, children, just that they are the heroes of the elements. They are the heroes of the metals. That means they are very reactive. They're very reactive. But like I have told you, even if I'm going to slap you, like some children may cry, some students, why miss bait me without any reason? Like in the classroom also, I gave you this example. So this is the different reaction given by the elements. So according to their reaction, the metals are arranged in the reactivity series. So at the top we have the two dhamake wale metals, that is sodium and potassium. Even if you cut it and keep it in the normal room temperature, they catch fire. Yes, they're they show exothermic type of reaction. Then calcium, at least it's mild one. In chalk, like we have the calcium oxide products, calcium or hydroxide products. If you observe, they show very mild reaction, children. When you put into water, they are going to show such mild reaction. Like for example, you take chalk powder and you add into water. It's not good. You will find bubbles onto that water. Yes, it's a kind of exothermic reaction, but we have seen in the previous classes, like if you add tuna, that is calcium oxide, calcium hydroxide, if you add into water, they show exothermic type of reaction. So sodium and potassium, look at the first two. When you you add into water, literally you're going to find lot of gas evolved, and also the reaction is highly exothermic, it's very exothermic. The next series, only one we have the calcium. When you what I'm trying to explain you children, that is how each and every metal reacts with water. This is very important now. Metal, when it reacts with water, what happens? So do they show any kind of reaction or no? So sodium, potassium, they react with water, okay, and they form alkalis, they form the bases. Then we have the calcium, it also reacts with water, and but it's a kind of mild exothermic reaction. But you are going to find the calcium, it starts floating on the top. When you try to do this, when you add chalk powder into water, you will find the chalk powder you will find on the top it starts, it bubbles up, and you will find that on the bubbles you are going to find the some amount of water, some amount of calcium is floating on the top. This happens because it does not react in a complete way. It shows because it carbon dioxide gases evolved, you will find the bubbles, yeah, that bubbles, and obviously the calcium also floats on the top. So next one we have the calcium, magnesium, aluminum, carbon. Carbon is not included here, just I'm going to erase that. Next one, zinc, iron, tin, lead, copper, silver, gold, platinum. The materials which we use in our day-to-day life, where are those children? Okay, they are at the bottom, they are at the least, they are the least reactive. Copper vessels we use nowadays, at least rarely we use, but we have the copper bottom. Just go enter your kitchen and you will find there are some different vessels in your house which are steel, and they have the steel that they have the brownish color bottom. That brownish color bottom is the metal copper, because copper metal, it is a good conductor of heat, so it is used at the bottom. So we have some copper bottom vessels. Then silver we use in our day to day life, silver articles, yeah. Then we have gold, the platinum, it's very expensive, but these all copper, silver, gold they are at the bottom, they are at the least reactive, they are considered as the least reactive, and which we use in our day-to-day life. Can we use this all sodium, potassium, calcium? They are mainly used in the factories and industries for for preparing medicines, for preparing some chemical compounds. Okay, so one more thing children, I'll just show you something. Look at this, this is very important, how you will remember this children. Okay, how you will remember this. Potassium, sodium, calcium, magnesium, aluminum, this is series. I'll just show you how you are going to remember it along with the symbols. We have you just take the initials. Please stop calling me a zebra. Please potassium. Stop sodium. Calling calcium. I think I have told you earlier, but even though it's a kind of revision, please stop calling me a zebra. Instead is iron. Zebra is zinc. Iron. Instead, okay, instead, towards is tin, towards lead, copper, silver, gold. Platinum at least will not include here. Please stop calling me, because those are at the top and those are important. So remember, please stop calling me a zebra. Instead tin, instead towards lead, copper, silver, gold. Okay, so please stop calling me a zebra. That's it, you have to remember. Please stop calling me a zebra. That means P for potassium. Please then sodium, calcium, magnesium, aluminum, zebra, zinc, and then instead, that is iron, towards, that is tin, lead, copper, silver, gold. So this way you will remember the series. Please stop calling me a zebra. Instead, towards, lead, copper, silver, gold. Okay, so this was the you'll remember, this is the way you will remember the series. And let's see children, first thing, recently we like, if you observe, like okay, fine, this is reaction with metals. So this is completely dependent on the reactivity series. Okay, reactivity series. Now first three elements, that is sodium, potassium and calcium. Okay, the first three elements were sodium, potassium and calcium. Look at this, sodium, potassium, sodium, calcium. These three metals, at least, they react with cold water. Okay, now in your house also, if you observe your mother, she boils water and she may, just give an example. Every person in your family Okay, they just consume different like I'm not saying types of water because we don't have types of water, but different, like you're going to find some they may drink warm water, some may have the habit of drinking chilled water completely, literally they will dump the bottle in the refrigerator, very chilled water. So this is the category. So same way, even the elements, even the metals, they react in a very different way. Like first three elements, sodium, potassium and calcium, they can react with cold water, thanda pani bhi chalta hai, okay, reaction, they react easily with cold water. So sodium, potassium and calcium, easily they react with cold water. We have to remember this, huh? Then next one, aluminium, iron and zinc. Okay, this is, and whatever I am telling, it is related to the periodic table. First three at least thande pani chalega, okay, that is the cold water, it reacts with cold water. Magnesium, aluminium and zinc, they are very hi-fi ones, okay, they react with steam, they don't they don't they like they cannot react with normal